Hello YouTubers and welcome to another episode of Cracking Irodov. Myself Pranav Singhal doing a community service for you by giving the solution of this wonderful book, and our today's topic is question number 1.16, and that question says two particles 1 and 2 move with constant velocities v1 and v2 along two mutually perpendicular straight lines towards the intersection point O. At the moment t is equal to 0, the particles were located at the distances L1 and L2 from the point O. How soon will the distance between the particles become the smallest? How is it equal to? So the question is really very simple. We simply have to use a lot of calculus in these questions, and if you don't know what the word is called calculus or what this fancy word means calculus, then please review your classes about what is calculus, what is maxima and what is minima, how can you differentiate with respect to different variables, etc, and this will really help you. So let's just focus on the picture of this question that says 1,000 words. Let me say the intersection point O is over here, and this particle A means the particle first started from this point. Let me name this as A and this as B. So if I draw a straight line over here like this, and another straight line, I think it's not straight, I'm trying my best to make it a straight line. This over here is equal to L2, and this over here is equal to L1. So if we write let at time t the distance between the particles was shortest, I think you are comfortable with my writing part, so it doesn't matter. So after t seconds, what will be the distance covered by particle A? If it is moving here with a velocity v1, right over here, then after t second it will come over here, and this distance will be equal to, as we know the velocity is uniform and it takes time t to reach here, so it would be simply equal to v1t. And similarly from this, for particle B, this is moving with velocity v2, and after t seconds this would have moved v2t distance. Say distance displacement would mean the same thing as the object is moving in the same straight line, so it doesn't matter what we are taking. Next we focus on what this distance is equal to. This distance will be simply equal to, this whole is L1 and this is v1t, so this is simply equal to L1 minus v1t, and this distance over here, not this distance over here is simply equal to the whole L2 minus v2t. This is simply as cutting into pieces, but it is a physics question. Now if I name this point as C, this as D, what about this distance CD? Let CD be x. Then accordingly x is the shortest distance, as I am taking the variable t to reach the shortest distance at C and D points respectively. So if you have read about what is a maxima and minima, then you must know that a minimum point over here is equal to a minima. The differentiation of a minima is equal to 0. At the minima or maxima, the slope of a function, the slope of a derivative is equal to 0. So we will simply find what our x is equal to. According to Pythagoras theorem, Pythagoras was really a very great guy. I must say, I must quote over him. He was the brilliant guy that I have ever seen in my life. First place of course goes to Newton, second goes to Einstein, and third goes to the great guy Pythagoras, as this triangle rectangle property is used in many cases, as you can see in this question also. So let's focus on the question. Our x will be equal to, or we can say our x square will be equal to this distance square, that is L1 minus V1t whole square plus L2 minus V2t whole square. I think it is clear to you. Now if we differentiate the equation with respect to time, differentiate the equation with respect to time. I think you are comfortable with my language. I am saying this again. If you are not, please comment below. I will try to improve my language in the next video if possible. So let's focus on what will be a differentiation with respect to time for x square. You must know the calculus very hard to do such type of questions. We will write dx by dt over here, and over here 2L1 minus V1t. I think you should know the cross product rule. So first we will take the outside part, 2L1 minus V1t, and then we will differentiate the inner part, that is L1 minus V1t. L1 becomes L1 and minus V1t becomes simply minus V1. Let me write the formula. Differentiation of x simply equal to nx n minus 1. This formula is very important. This is called power rule. We are simply applying that. For a constant, this is equal to 0, as the power of x then becomes 0. So here it comes that, and next is differentiating this 2L2 minus V2t. First the outer part means the outer part, then the inner part, that is equal to L2 minus V2t. So L2 becomes 0 and what we remains is minus V2. As t was 1 power, it cancels out as t is power 0. So here's our equation for dx by dt to be minimum. This should be a minima, means the slope over here should be equal to 0. I think it is clear to you. I have also explained this in my previous videos. So let us put dx by dt is equal to 0 in equation 1. Let us put it. So here it would become 0, and from here we can simply write it as minus 2 v1 l1 plus 2 v1 square t, and here it is simply minus 2 v2 l2 plus 2 v2 square t. From here we can easily find out the value of t. Taking t as common here, we get 2v1 square plus 2v2 square, which is in turn equal to this value over here, 2v1 l1 plus 2v2 l2, and we can simply get time as 2 cancels out with each other, and this we remain with this thing over here. So this is our first answer to this question, first part, sorry. So our question was saying, let me recap, that what will be the time between the particles when their distance should be shortest, and what that distance is equal to. That's the question. That distance we have to calculate as x over here. If we put the value of t over here, we can simply find out the value of x. This should become under root, the value of x then would be equal to, if we put that in that equation, this will be a long under root, I would say, a very long under root. L1 minus v1, L1 minus v1, there comes L1 v1, v1 L1 plus v2 L2 upon v1 square plus v2 square whole square, and similarly for next term we will get it as equal to L2 minus v2 v1 L1 plus v2 L2 upon v1 square plus v2 square whole square. I am not simplifying this equation right here, as the video would become very long, so I would simply write the answer as as, let me check what my answer, my rough answer was coming. Yeah, I have calculated the answer, simplified the equation, and my answer was coming L1V2 minus L2V1. L1V2 minus L2V1 in mod. And that here we get under root V1 square plus V2 square. That is our final answer for the shortest distance. You may be very confused why there is a mod sign over here. What do you mean by mod sign? This is the modulus of this equation. So if I would have seen the displacement, so it is the distance, not the displacement. So the mod sign is really very helpful over here, as we are calculating distance, not the displacement. I hope it would have been clear to you. Thank you for watching my video and subscribe to my channel.